Hola, hi, this is Al Nozal, your probability and statistics instructor. Okay, let's get to work. In this video, I will give you an overview of Statistics 256, which gives us the basic tools for constructing and analyzing mathematical models for random phenomena. In probability theory, we are concerned with an experiment with an outcome depending on chance, which is called a random experiment. It is assumed that all possible different outcomes of a random experiment are known, and they are elements of a fundamental set known as the sample space. Each possible outcome is called a sample point, and an event is generally referred to as a subset of the sample space having one or more sample points as its elements. Okay, now let's consider an example to make our discussion more concrete. This example will illustrate some important concepts of a probability model. These concepts are A. Random experiment, B. Outcome or sample point, C. Sample space, D. Event. Got it? Okay. Now, if possible, pause this video and go to your nearest convenience store and purchase a box of Smarties, like the one I'm going to show you here. Another choice would be doing that, getting a box of Smarties like that one, after you have watched this video. Okay? So, next step. Let me present the random experiment that we are going to discuss. That's a random experiment. Drawing a single piece of candy from one of those little boxes. Oh, let me show you what little boxes I have in mind, right? So the big box contains 10 little boxes like those, okay? Okay. Now, our ultimate goal is finding the probability of drawing a blue candy, okay? So, our first step in formulating a probabilistic model for this experiment will be providing a list of possible outcomes, that is, the sample space. Well, it turns out that in this case, that is the list of possible outcomes. One of 8 colors: red, orange, yellow, green, purple, pink, blue, or brown. Okay? Soon we will see that in probability theory we are interested not only in what particular outcome occurs as a result of a trial, but in whether the outcome belongs to some subset of the set of all possible outcomes, the sample space. This leads us to our next concept, event. An event is any subset of the sample space. We will talk in more detail about events in another video. But Here, let me show you an example of an event. Okay, for instance, blue or red would be an event. Okay, another example would be blue and red. And another example would be not blue. Okay? Notice that starting from a given collection of sets that are events, we can form new events by using or and not, which, if you remember, they correspond in the language of set theory to the operations union, intersection, and complement. Well, we will discuss these operations in more detail later in another video. Okay? Anyway, our interest in studying events will also motivate us to consider a special class of subsets, a class of subsets of the sample space. This special class of subsets is called a Borel field. We will talk about Borel fields a little more in the near future, not in this video. Next, we would like to introduce another element into this model, a mathematical representation of probability, because remember that our ultimate goal is finding the probability of blue. Okay? So, we are interested in defining what is meant by the probability of an event A, denoted by P brackets A. We will talk about notation also later, and we often call that number the chance of A occurring. Okay? Probability is used to quantify the likelihood or chance that an outcome of a random experiment will occur. Well, the likelihood of an outcome is quantified by assigning a number from the interval 0, 1 to the outcome, okay? And you could think about that number also as a percentage from 0 to 100%. Higher numbers indicate that the outcome is more likely than lower numbers. A 0 indicates an outcome will not occur. On the other hand, a probability of 1 indicates an outcome will occur with certainty, for sure. Probabilities for a random experiment are often assigned on the basis of a reasonable model of the phenomenon under study. A very popular approach is to base probability assignment on the simple concept of equally likely outcomes. So, how would that work? In our case, we have 8 different colors. So the equally likely approach would assign a probability of 1 over 8 to each of those colors, right? Make sense? By the way, we will spend a considerable amount of time in this course learning about several reasonable probability models. A second interpretation of probability is the following. The probability of an outcome can be interpreted as our subjective probability, our degree of belief that the outcome will occur. Different individuals will assign different probabilities to the same outcomes. For example, based on my experience, I would say that the probability of red, orange, and purple is the same in around 15%, and on the other hand, the probability of yellow, green, blue, purple, and brown are also the same, but a lower. I would assign a lower percentage to those events. Okay? So something like this. That's based on my experience. And maybe, right, somebody else, if you ask one of your classmates to do a similar assignment, they would use different numbers for the probability of each of those events, right? Okay. So, using this idea, right, the probability of brown is 11%. But if we just saw that the probability of blue, using the equally likely outcomes approach, would be 12.5%. Okay, and makes sense. I mean, two different approaches, maybe they will lead to a different answer. Okay, so another interpretation of probability is based on the conceptual model of repeated replications of the random experiment. The probability of an outcome is viewed as the limiting value of the proportion of times the outcome occurs in n repetitions of the random experiment as n increases. Okay? So, example. Let me show you a graphical representation of the results I got based on drawing 100 Smarties. Okay, I think I got it here. Yeah. See? So, from this graph, we can estimate the probabilities of each color. Let's do that for red. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, right? So using that relative frequency interpretation approach, the probability of red would be 15%. And we could do the same with the other colors, right? The one that we're interested in is blue, right? So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so the probability of blue using this approach would be 11%. Okay, so that would be the probability for all the possible outcomes of this random experiment. Okay, bottom line, the one that we're interested in, 11%. Okay, let's recap. Probability theory, this course, will give you the tools to construct and analyze random experiments. Important components to provide a mathematical description for random experiments are: number one, the sample space. That is the list of all possible outcomes. Okay? 2, chances are we will be interested in more combinations of outcomes from the sample space. These combinations will be formed with operations from set theory: union, intersection, complement. Any subset of the sample space will be referred to as an event. That's just, the word that we're going to be using to refer to that, a subset of the sample space. Okay. 3. The probability of an event will be a number between 0 and 1. And this number measures the likelihood of the occurrence of the event of interest. 4. Something that we also learned is that there are different ways of assigning probabilities to events. In this course, we will concentrate on constructing and applying a wide variety of different reasonable probability models. We will be talking about these ideas in more detail in Statistics 256. Okay, that's it for now. Please take care and work hard. See you next time. Bye.